Okay, class. Now we want to learn, what is the relationship between the area under a speed time graph and the distance travel, area. We want to see this relationship. Okay, we look at example, So first, you are asked to calculate. We will calculate area under speed time graph and distance travel. Okay, how we do it? Okay, look at this statement. Encik Faisal drives a distance of 200 kilometers in 4 hours. Okay, first we find the speed first. So speed, the formula is distance over time. So we will get 200 kilometer divided by 4 hours. You will get 50 kilometer per hour. Okay, now we do the speed time graph. So when we get this 50, okay, this is the 50 that we calculated just now, and this is the 4 hours. So the graph is here. This is the graph. And next, we find the area under the graph. Okay, what do you understand by the area under the graph? This is your graph. Area under the graph is this one. This is the area. This is the area under the graph. What shape is this? Yeah, this is a rectangular. So you use the formula of a rectangular. That is length times width. This is your length, this is your width. So your length is 4 hours, and then your width is 50 kilometer per hour. So you get 200 kilometer for your area. And then we find the distance travel. Okay, how to find the distance travel? We use the formula. This formula we are used to already. You still remember? DST. So this distance is speed times time. That's why you get this one. Okay, speed you know it's 50 kilometer per hour. Time is 4. So you get 200 kilometer. Okay. Okay, now you see we find the area. Okay, under the graph we get 200 kilometer, and then we find the distance using the formula. We get 200 kilometer also. So is it a coincidence, or there is a relationship between the area and the distance? Okay, we go to another example. We cannot make a conclusion now. We look at another example. Okay, a tour bus moves 150 kilometer in 2 hours. In 2 hours. So we can find the speed. The speed is 150 kilometer divided by 2 hours. So you will get 75 kilometer per hour. Okay. Now we draw the graph. Okay. This is speed. Kilometer per hour. This is time. Hour. So you get 75, right? The speed 75 kilometer per hour, and then the time is 2 hours. Huh? So your graph should be like this. Huh? Okay, and this one is 2 hours. Yeah, and then you find the area. So area is once again, this is the area. Yeah, this is the area under the graph. Okay, so this one a bit over. Let's see. Okay, this is the same shape, rectangular also. Okay. Then area is 75 times 2, so you get 150 kilometer. Okay, then we find the distance travel equal speed times time. Your speed is 75 kilometer per hour times 2 hours. Yeah, so you'll get also 150 kilometer. Yeah, so once again, you'll get the same answer. Your area and your distance same, 150 also. Yeah, so we can make one conclusion here. We can make one conclusion that the area under a speed time graph is the same as the distance traveled for the same time interval. Yeah, so if you have this graph, yeah, this is your speed, this is your time, and then you have it doesn't mean always rectangular. If you have like this one, yeah, your speed is this one, your graph is like this. So what do? You can find the distance travel for the speed time graph. Actually, you can find the distance. Yeah, how to find the distance? You just find the area under the graph. So you must know the shape, yeah, the shape of the area under the graph, yeah, not above the graph, not at the side of the graph, but under the graph here. Yeah, you can see here. So depends on the shape. What shape is this? It's trapezium. So it's, you find the area of the trapezium. Yeah. So you can make one conclusion here. For a speed time graph, area under the graph, yeah, area under the graph here is the distance traveled. Yeah. So you have to copy this. Copy. This is very important. Next, we look at example. Yeah, we look at example. 12. Calculate the distance traveled each motion based on the following speed time graph. Okay, this is your graph, speed time graph. And what do you see here? Yeah, you see a graph. And under the graph, because you know that you can find the distance, you just find the area under the graph. So you must know the area is here. So what shape is this? This is a trapezium. Yeah. So you have to use the formula of a trapezium. Yeah. So this is 5. This one is 5. And then this one is 10. Yeah. And then here, of course, it is 4/5. Yeah. So remember the formula of trapezium. This is the parallel line. You have to add the parallel line. Yeah? So the formula is 1/2 times the height. Yeah, this is the height. And then times the parallel line you add. Yeah, you add the parallel line. So you get 3 kilometer. Yeah. Okay. For this one, it's the same also. Yeah, it's the same. This graph, under the graph is here. Yeah, under the graph. Can you see that? Under the graph is this one. Yeah. So again, it is the shape of a trapezium. So you just get the numbers. Yeah, the length here. The length is 80. Here it is 40. Yeah, and then the height is the height. It is 6. Yeah, it is 6. But because this is minutes, this is hour. Yeah, so you have to put this one into hour. Yeah, so you divide by 60. So you get this one 6/60. It's already in hour. And then you add the parallel line. This one, the parallel line, you add, and then you will get 6 kilometer. Yeah, 6 kilometer. So that is the distance travel. Easy. You just find area and then you get the distance. Okay. We go to example 13. Example 13. The speed time graph shows the speed of Mr. Leo's car for a period of 36 minutes. 36 minutes. Calculate the total distance in kilometer traveled by Mrs. Liu's car for the period of 36. That means all here, yeah, the graph. What do? You find the area, all the area under the graph here, yeah. And then, what shape is this class? Never see this shape before, like a mountain. So how to do it? Actually, you can divide. You can divide the shape. First, you can see the, what do you see? You will see a triangle. Yes, you see a triangle. And then after that, you see this one. This is a trapezium. And then after that, you see what? You see another one. Another one here. This is another trapezium, right? Another trapezium. Okay. So you have three shapes here. So the distance travel is area under the line. This one you should know. And then, so the first area is the rectangle, triangle, yeah, 1/2 times, this is 10, you change into hour, you divide by 60 times 72, this one, this is the height, yeah, this one is this one, yeah? Okay, the height is 72, and then the length is 10, yeah? So you just use the formula. Okay, next is the trapezium. So still 1/2 times. So this one the difference is 10. This one 10. 10. Okay, because you want to change into hour, you divide by 60. And then the parallel line is 40 and 72. Okay. Then next, the red trapezium. The red trapezium also from 20 to 36. 36 minus 20, it's 16. Yeah? That's why it's 16 here. Divide by 60, and then 40 plus 72 is the same. Yeah, same with this one. Okay, you just use your calculator and you will get the answer, 30.27 kilometer. Yeah. Okay, next you want to find the average speed in kilometer per hour of Mrs. Liu car for the period of 36 minutes. So this one you use the formula. Average speed is total distance over time. Yeah. So your distance, you use this one, and then your time is 36. Yeah. So, but remember to divide by 60 because you want to have your answer in hour. Yeah. So you'll get this one. Yeah. So that's it. Our lesson for today. I hope you can understand. If you don't understand, you can always ask me or you can repeat the video. Yeah. Okay, that's all. Bye bye.